In July 2024, something strange happened in Northern Virginia. 60 data centers dropped off the electric grid at almost the same time. There was no hurricane, no explosion, no cyber attack. A voltage disturbance was enough. In seconds, roughly 1,500 megawatts of demand vanished from the system. That is the size of a large power plant suddenly disappearing from the grid, not because it stopped producing electricity, but because the customers stopped taking it. Grid operators stabilized the system quickly. The lights stayed on. But the incident exposed something Silicon Valley does not like to say out loud. Artificial intelligence is not just a software business anymore. It is an electricity business. For years, the technology industry sold the same beautiful idea. Everything was moving to the cloud. Your files were in the cloud. Your photos were in the cloud. Your business software was in the cloud. Your entertainment was in the cloud. The word made it sound light, clean, almost magical. But the cloud was never a cloud. It was land, concrete, steel, diesel generators, cooling systems, fiber lines, transformers, substations, transmission access, and thousands of servers pulling electricity every second of every day. Artificial intelligence did not create that physical reality. It simply made it impossible to ignore. The old internet could grow quietly in the background because its energy needs were easier to hide. Search engines, social media, streaming platforms, and cloud storage were already large consumers of electricity. But generative AI changed the scale and the intensity of the load. The new AI race is not only about who has the best model, the smartest engineers, or the most advanced chips. It is about who can secure enough reliable power in the right place at the right time before everyone else gets there first. A lot of people talk about AI energy use by arguing over one question: how much electricity does a single AI query use? Older estimates suggested that one generative AI query could use around 2.9 watt-hours of electricity, almost 10 times more than a traditional web search. Newer estimates are lower, closer to a fraction of a watt-hour for a typical text query on modern systems. That debate matters, but it can also be misleading, because the problem is not one person asking one chatbot one question. The problem is billions of questions, image generations, code requests, voice agents, business automations, recommendation systems, training runs, fine-tuning jobs, and background processes happening at the same time. A single query may not sound dramatic, but a global AI economy running all day, every day, turns software into industrial load. That is the shift. Data centers are no longer just digital filing cabinets. The largest AI facilities are starting to look more like factories, except instead of producing steel, chemicals, or aluminum, they produce computation. And like any factory, they need power. The International Energy Agency estimates that data centers consumed about 415 terawatt-hours of electricity in 2024. That was roughly 1.5% of all electricity used in the world. That number may not sound enormous until you realize two things. First, data center demand has been growing much faster than overall electricity demand. Second, it is not spread evenly around the planet. The IEA projects that global data center electricity consumption could more than double by 2030, reaching around 945 terawatt-hours. That is slightly more than the current annual electricity consumption of Japan. And the United States is at the center of this. In 2024, the U.S. accounted for the largest share of global data center electricity consumption. The IEA estimates that U.S. data center electricity use could rise by about 130% by 2030 compared with 2024. In other words, the AI boom is not just adding a little extra load to the system. It is becoming one of the main forces reshaping power demand in the United States. Recent U.S. utility forecasts reviewed by Grid Strategies project 166 gigawatts of peak demand growth by 2030. Data centers account for roughly 55% of that projected growth. That does not mean every proposed data center will actually get built, but it shows what utilities are now being asked to prepare for. After decades in which American electricity demand was relatively flat, planners are suddenly being told to get ready for industrial-scale growth again. This is where the story gets misunderstood. People often talk about electricity as if it were one big pool. If the country produces enough power somewhere, then the problem is solved. But electricity is not useful in the abstract. A megawatt in the wrong location does not help a data center that needs power hundreds of miles away. A solar farm waiting for a grid connection does not help a new AI campus that wants to open in 2 years. A wind project stuck in a permitting queue does not keep a server cluster online tonight. For AI companies, the scarce resource is not simply electricity. It is firm, reliable, deliverable power, connected to the right grid node, backed by the right transmission capacity, and available at the exact location where the data center is being built. That is why the power race is moving from press releases to land deals, power purchase agreements, nuclear restarts, gas plants, and behind-the-meter arrangements. A data center can sometimes be built in 2 or 3 years. Transmission lines, substations, transformers, and new generation can take much longer. That mismatch is now one of the biggest bottlenecks in the AI economy. There is already a huge backlog of energy projects trying to connect to the grid. At the end of 2025, more than 2,000 gigawatts of proposed generation and storage capacity were sitting in U.S. interconnection queues. That does not mean all of those projects will be built. Many never will. But the queue shows how congested the system has become. The United States has plenty of proposed clean energy on paper. Solar projects, wind projects, battery projects, and hybrid systems are all waiting for permission to connect. The problem is that paper projects do not power AI data centers. Connected projects do. And the companies building AI infrastructure do not want to wait 5, 7, or 10 years for the grid to catch up. So they are doing what large companies always do when a public system becomes too slow for them. They are trying to build a private path around it. They are signing direct power contracts. They are buying land near power plants. They are exploring on-site generation. They are looking at nuclear. They are looking at gas. They are looking at batteries, geothermal, and small modular reactors. They are no longer just buying electricity. They are trying to control the pipeline that delivers it. This creates a problem for the public image of big tech. For more than a decade, the largest technology companies presented themselves as leaders in the clean energy transition. They signed renewable power deals. They published sustainability reports. They promised net zero emissions. They spoke about carbon-free energy and climate responsibility. But AI growth is now colliding with those promises. Google reported that its greenhouse gas emissions were 48% higher than its 2019 baseline in its 2024 environmental reporting. Microsoft said in its 2024 sustainability report that its total emissions were up 29.1% from its 2020 baseline. These increases are not only about electricity flowing into servers. A large part of the problem is the physical build-out itself: data centers, chips, construction materials, supply chains, backup systems, and the enormous industrial machine required to scale AI. This is the contradiction. The same companies selling the future as clean, digital, and efficient are now building one of the most electricity-intensive infrastructure expansions in modern history. They are not abandoning climate language. They are learning that climate promises are much easier to make when your business model is not trying to consume power like a heavy industrial sector. This is why nuclear power is suddenly fashionable again in Silicon Valley. Nuclear has problems. It is expensive. It is politically difficult. It can take a long time to build. The industry has a long history of delays and cost overruns. But it has one feature that AI companies desperately want. It can provide large amounts of carbon-free power around the clock. Solar and wind are cheap and essential, but they are variable. Batteries help, but they do not solve every 24/7 power problem at this scale. Natural gas is flexible and fast to deploy, but it creates emissions that clash with climate pledges. Nuclear offers something different: dense, steady, high-capacity electricity. That is why Microsoft signed a 20-year power purchase agreement with Constellation Energy to support the restart of 3 Mile Island Unit 1 in Pennsylvania. This is not the reactor involved in the 1979 accident. That was Unit 2. Unit 1 is separate and had been shut down for economic reasons. Under the new plan, it will return under a new name, the Crane Clean Energy Center. The symbolism is hard to miss. A nuclear reactor that could not survive the old electricity market may be revived because AI data centers need reliable, carbon-free power. Amazon has taken a different route. In 2024, Amazon Web Services bought a data center campus next to Talen Energy's Susquehanna Nuclear Station in Pennsylvania for $650 million. The logic is simple. If the biggest bottleneck is getting power from the grid to the data center, then build the data center as close to the power source as possible. Later, Talen announced a power purchase agreement to supply AWS data centers in Pennsylvania with up to 1,920 megawatts from Susquehanna. That is not a small corporate clean energy deal. That is power at the scale of a major city. But these arrangements also create a political fight. If a large technology company pulls electricity directly from a power plant, what happens to the public grid? Who pays for transmission upgrades? Who pays for reliability? Who pays when the grid needs new capacity because one giant customer is changing the economics of the system? Utilities and regulators are now asking those questions. Because the future of AI is not just being negotiated in software labs, it is being negotiated in utility filings. Microsoft and Amazon are not alone. Google signed an agreement with Kairos Power to support up to 500 megawatts of new advanced nuclear power, with the first deployment targeted around 2030 and additional deployments through 2035. Meta announced a request for proposals seeking 1 to 4 gigawatts of new nuclear generation capacity in the United States to support its AI and sustainability goals. These are not normal software company moves. A social media company asking for gigawatts of nuclear power would have sounded absurd 20 years ago. Today, it is part of the business plan. The AI industry is creating a new alliance between two worlds that used to feel separate. On one side, algorithms, cloud services, recommendation engines, chatbots, and digital platforms. On the other side, uranium, turbines, cooling systems, substations, transformers, grid operators, and regulators. The future of artificial intelligence is being built out of both. The obvious answer is to say, fine, let big tech pay for its own power. And in many cases, these companies do pay enormous energy bills. They sign large contracts, they fund projects, they buy renewable energy, they invest in new technologies. But the system is not that clean. Electric grids are shared infrastructure. When utilities build new transmission lines, substations, gas plants, or reliability upgrades, those costs can end up spread across many customers. That means ordinary households can be affected even if they never asked for an AI data center in their region. The bill can show up indirectly. Higher capacity costs, more expensive grid upgrades, new power plants, transformer shortages, delayed connections, or rate cases where utilities ask regulators for permission to recover investment from ratepayers. This is where the AI boom becomes political. The fight is not only whether data centers should exist. The fight is who pays for the infrastructure that makes them possible. Tech companies get the upside. Cloud revenue, AI subscriptions, enterprise contracts, advertising systems, and market dominance. Local communities may get some jobs and tax revenue. But they may also get higher bills, water stress, land use fights, backup generators, transmission corridors, and a grid planned around the needs of a few enormous corporate customers. That is the hidden bargain behind the AI boom. Electricity is only one part of the resource story. Data centers also produce heat. A lot of heat. And heat has to be removed. Depending on the cooling system and the local climate, that can mean significant water consumption. The old version of this story often gets exaggerated. A mid-sized data center does not consume 300 million gallons of water every day. A more realistic figure is closer to hundreds of thousands of gallons per day for some mid-sized facilities, while very large data centers can consume several million gallons per day. That is still a serious local issue. Because water, like electricity, is not an abstract global number. It is local. A gallon of water in a wet region does not help a dry region. A data center built near a stressed aquifer is different from one built where water is abundant and cooling needs are lower. One recent study estimated that if 2024 water use intensity continues, U.S. data centers could collectively require hundreds of millions to more than 1 billion gallons per day of additional water capacity by 2030. That turns AI from a software story into a municipal infrastructure story. It becomes a question for local governments, water utilities, farmers, homeowners, and everyone else competing for the same resources. The most absurd part is that not all of this electricity is used intelligently. A 2026 industry report estimated that around 13% of U.S. cloud consumption supports so-called zombie workloads, systems that continue running while doing little or no useful work, abandoned test environments, forgotten applications, idle cloud instances, databases nobody turned off. The exact number can be debated, but the concept is familiar to anyone who has worked with cloud infrastructure. The cloud makes it easy to start things. It does not always make it easy to remember what should be stopped. So while the largest technology companies are scrambling to secure nuclear plants, gas turbines, transmission access, and water capacity, part of the system is still wasting energy on digital leftovers. That is the final irony. The AI industry says there is not enough power for the future, but inside the same infrastructure, there are still machines burning electricity for work nobody needs. This does not mean artificial intelligence is useless. It does not mean data centers should be banned. And it does not mean every new power project connected to AI is automatically bad. AI may create real productivity gains. Data centers can support useful services. New power demand can also push investment into cleaner energy, better grid planning, advanced nuclear, geothermal, batteries, and more efficient infrastructure. But it does mean the story is much less magical than the marketing. The AI boom is not floating above the physical world. It is digging into it. It needs land. It needs water. It needs chips. It needs steel. It needs copper. It needs transformers. It needs transmission lines. And above all, it needs electricity. The company that wins the AI race may not simply be the one with the smartest model. It may be the one that locks up cheap, reliable power first. That is why the largest technology companies are moving deeper into the energy business. They are not doing it because they suddenly became power companies. They are doing it because AI made power the limiting factor. For decades, Silicon Valley told us the future would be weightless. No factories, no smokestacks, no heavy industry, just software eating the world. But software did not escape the physical world. It outsourced it. And now AI is bringing the bill back. The cloud was never a cloud. It was a machine. And the machine is hungry.